Howdy everyone! So in this video here we're going to be looking at solving simultaneous equations, and this one specifically by substitution. So firstly, we can use this substitution when we know what one variable is equal to. So you'll see in all these examples here, we'll know what one variable, specifically y, is equal to. So this first one, y is equal to 3x. So we know exactly what y is equal to. Okay? So we're going to go through this. Just remember, if you've got two equations or two variables, you need two equations to work out what they are equal to. Okay, so our first one, x plus y is equal to 8, and then we have y is equal to 3x. So what we're going to do is we're going to substitute this value of y, so this 3x, let's see if, there we go. We're going to substitute this 3x in for this y value, because we've said in this second statement that y is the exact same as saying 3x. Okay, so we're going to do and you can always write this by just saying we're going to sub equation 2 into 1. Okay, it's always good just to state what you're doing, just so you can follow on, or those that are correcting can follow on. So this becomes x plus 3x is equal to 8. We need to collect like terms, x plus 3x, so 1x plus 3x is equal to 4x is equal to 8. And now we need to get x by itself. So 4 times x, we need to divide by 4. Divide by 4. So x is going to equal 2. Now we have a value for x is equal to 2. We're going to sub substitute this into one of our equations, and hopefully you realize it's a lot easier to substitute it into this second equation here because y is already by itself, so you won't need to rearrange the equation at all to figure out what y is, because that's what we need to do to figure out what y is. Okay, so y is equal to 3 times 2. This is going to be 6. So it's always good for this just to write a statement at the end. So these 3 dots, this just means therefore x is equal to 2 and y is equal to 6. Okay, so that's how you go about solving these. We'll go through the next two. So we have 3x minus y is equal to 9, and you'll see here y is equal to 4x minus 11. So this one's a bit longer, you'll notice. Instead of just having 4x, we've got 4x minus 11. But it's the exact same theory. We put this 4x minus 11 where this y is. Okay? So just make sure that all of this is going to be minused, and I'm going to show you how to do this. So we're subbing equation 2 into 1. Okay, so we're going to have 3x minus, and it's always good to put brackets here. So it's going to be minus 4x minus 11 is equal to 9. So I'm just going to expand out these brackets. So 3x is minus 4x, and just remember this minus is going to be multiplied by minus, so this is going to be a plus 11 is equal to 9. Now I'm going to collect the like terms of 3x minus 4x. So 3x minus 4x is negative x plus 11 is equal to 9. So now we need to get rid of this plus 11 to get x by itself, or nearly x by itself, so we need a minus 11 to make negative x is equal to negative 2. Now we need to get rid of this negative sign, and we do this by multiplying negative 1. So x is equal to 2. Again. So now we just need to substitute this value, and we're going to substitute it back into equation 2 because y is already by itself. You can substitute it back in either of the equations, but it's a lot easier to put it in the one that y is by itself, so we don't need to do any rearranging. So we're going to sub x is equal to 2 into equation 2. Alright, so y is going to equal 4 times 2 minus 11. So 4 times 2 is 8, so it's going to be 8 minus 11, which is equal to negative 3. So I'm just going to write our statement at the end. Therefore, x is equal to 2 and y is equal to negative 3. Okay, so that's how you go about doing that. Our next one, okay, this is looking at when we have a number multiplying our y as well. Okay, so you'll notice we didn't have a number multiplying it in the last one, so it's just slightly different again. So we have 5x plus 3y is equal to 7. That's equation 1, and we have y is equal to x plus 5. So we're just going to do the same. We're going to sub equation 2, which is our y, into 1. So we've got 5x plus 3. So we put our bracket wherever the y is. So this is going to be x plus 5 is equal to 7. Okay, so we've got 5x, and it's going to be plus 3 times x, so we need to expand these brackets. 3x, 3 times 5, so 15. They're all positive because all of these numbers here are positive. Okay, positive times positive is a positive, and that's going to equal 7. Alright, we need to collect our like terms now, which are these two here. So 5x plus 3x is equal to 8x. Now we need to get x by itself, so we need to get rid of this plus 15. That's the furthest away, that's the easiest to get rid of. So we're going to minus 15. So 8x is equal to 7 minus 15 is negative 8. Okay, now we need to get rid of this 8, so we need to divide by 8, because it's 8 times x, so x is equal to negative 1. Okay, we've got our value for x, now we can find our y. So, we're going to sub x is equal to negative 1, and we're going to put this into equation 2 as well, because, yet again, it's the easiest one to put in, because y is already the subject of the formula. Okay, so y is going to equal negative 1 plus 5. Okay, so negative 1 plus 5, that is equal to 4. So, just going to write a statement stating both our answers. Therefore, x is equal to negative 1 and y is equal to 4. So, this is how you go about doing substitution. So, just remember some key things is just subbing these values back into your equation, like here. Watch out for negatives, like in B. okay, and making sure that you multiply all of it by the negative, and then just make sure, like in the third one, that you're expanding out your brackets properly as well, okay. So make sure you do 3 times x and then 3 times 5 as well. It's just little things that can cause some errors that will get you a wrong answer if you don't do it. So hopefully this helps with solving simultaneous equations by substitution, and good luck.